Welcome to What Is It About the Weather, where once a week we get together and explore the many ways that weather intertwines itself into our everyday lives. I'm your host, Mark Chalanik, and this week we're going to try to address the question of, can weather change time? Like sands through the hourglass, these are the days of our lives. Hope you're doing well. Hope you've had an enjoyable and intertwined weather week. Before we get too deep into the topics for today, let me take a moment just to say thank you. Thank you to all of you who are supporting the podcast. Those who are helping us stay cost neutral at places like Patreon, where you can check that out at patreon.com/weather. Those providing feedback and show ideas and thoughts and whatever it is, or just telling folks about the podcast so more and more people are hearing about it, subscribing, downloading, all those fun things. Whatever way you're supporting the podcast, it is appreciated, and thank you. Now, as we all know, we're in the middle of National Weather Podcast Month. You know, it's funny. Last year when we had this first time, I was kind of talking with everybody saying, let's not just do National Weather Podcast Month. Let's take the national off. Because I do have quite a few international listeners, and I didn't want them to feel excluded or not feel a part of it. And we're still calling it National Weather Podcast Month, but the website, if you go there, the domain doesn't have the national in front of it. So one small step, right? So weatherpodcastmonth.com. You can go there and learn about all the podcasts. Like I said, I think the episode in 2 weeks, as we get towards the end, I'll do a little more deeper dive into all the participants and the styles of maybe each of the podcasts to give you a sense of if you want to check them out, if you haven't in the past. But for now, that should give you a place to go to learn a little bit more. I did participate in something that was very related to that. So many of you know I've been on WeatherBrains before, which is kind of, I guess the best way to describe it is the granddad of weather podcasts. They've been around for almost 13 years. And it's an ensemble setup, and they tend to have, a guest and, maybe a couple of guests on, but they've got a wide array of hosts, okay, that are anywhere from broadcast meteorologists to people who work for the National Weather Service. But this week, they decided very nicely to have all of us on that do other weather podcasts. So we were able to kind of have a panel, if you will, of other podcasters. And we did talk some about the research I did. So I got a chance to go back on there and have a chat with the group about that and, a variety of other topics that we covered. So if you're interested in maybe getting an initial glimpse into what some of the other hosts are like, you can check out the latest WeatherBrains episode, which is episode number 633, and that is over at weatherbrains.com. Okay, let's dive into the main topic. Can weather change time? Can weather change time? Now, clearly weather and time have quite a history together, right? I mean, it goes all the way back to Mother Nature, who is in charge of weather, right? And Father Time. So, they've been married a very long time, if you will. Now, I will tell you, this is one of those episodes that's going to mostly be a little lighthearted, have a little fun with it. And part of that has to do with the whole planning process of different episodes. And I've told you guys this before. Some of the episodes I like to sort of wing it as I go along. I have had a lot of thoughts in my heads, maybe for heads, as if I have 3 thinking brains going on. I have 10 heads deciding what I'm going to talk about. No. There are, topics that I've been thinking about in my head for many years, right? Or that have been a recurring topic for me. And those are kind of easier for me. And a lot of times I like to just kind of wing it. So that it's easier in the sense that I just have a lot of built up information already in the thought processes that go along with it. I'll usually, even in those cases, still look to see if there's anything new or if there's any new thinking, or what prompted me to discuss it may have also been a recent event, an article that I saw or something along those lines. But still, I've got a lot of background, so I don't have to dig too deep for those. I have others where it's a topic that I think is interesting, and or I came across an article, but that's just a first glimpse. And I may not know enough, and it's scientific enough in its basis in nature to where I have to do a lot of refreshing, or the history episodes, right, where I look into a historic event. I may have no context to even discuss those. So I tend to do a fair amount of research. And again, that can vary on episodes. Some of these winged episodes may only be 4 hours of additional reading or whatever. But these other ones can be in the order of 10 hours of absorbing and trying to get through it and come up with an outline where I try to make sure I'm not going to be able to miss things that are key to the story. I don't do a whole script or anything, but I don't want to miss an important point or tell the story in an illogical way. And that can take time as well. As the history ones are an example. The more I dig into it, new information might become uncovered, or even the one last week where I was talking about stress relief. As I was going through the article and thinking about the key points, which I might pull out pretty quickly, but how to tell that in a podcast framework can take a little time to put together. Then there's episodes like this one that get planned, and again, my planning is usually, I'm thinking 4 to 6 weeks out most of the time, because I don't want it to get too far removed from it being fresh in my head. But with this Weather Podcast Month, we also had the situation where I was trying to put together episodes so we could publish a schedule. So it's a little further out. And the main reason for this topic this week has to do with the U.S. is about to go through daylight saving time change this weekend. So some of you are going to be listening to this. At some point, probably everybody that listens to this is going to utter some explicative comment with the word daylight saving time attached to it, whether you're getting it before or after. So that was the baseline for saying, I'll come up with something. And that really is what I was thinking. And I had heard some time kind of weather connected things in the past, but I really didn't have a lot to work with. And I made myself a few notes about things, but it wasn't a deep process. So as I was going and planning this stuff, so many little rabbit holes, so many different directions I could have gone. And so instead of going down one direction and doing a deep dive, I decided to touch on a lot of these things. And even listener feedback that I got recently kind of prompted me to do some of that. So I'm going to try to touch a lot of things, but it kind of means it's going to be a little lighter maybe in depth. And some of this stuff, getting into the exact cause or the exact reason doesn't achieve anything. And sometimes, the analysis paralysis or the investigation just for the sake of investigation doesn't lead anywhere. So just know that there's not going to be a lot of links about this scientific paper or, this well-written this and that. It's just a general thing. But hopefully we'll have some fun with it. All right, enough said. Let's talk about weather and time. Daylight savings time, right? That was the basis of kind of the starting point of all this. And I actually thought maybe I would find more of a weather connection since, there's talk about why we do it and, making sure that farmers had more time in the field at the right time of year. And so I thought, maybe there'll be a weather connection. But as you can imagine, maybe there wouldn't be. Now, we do say spring forward and fall back, so we attach it to the seasons. So there's a connection there. And this is particularly the bad one. Everybody hates the spring forward. Everybody loves the fall back. But it is interesting in that there is somewhat of a weather connection. And the way I knew about this is a lot of personal weather stations, including ones that I've had and set up over time, collect data. But they tend to collect it around local time. And what that means is when you do these time changes, you're either erasing data that you already had when you fall back and you're re-recording an hour, or you get this gap when you spring forward. Now, the reality is this doesn't really have much of an impact because while this happens with personal weather stations, not all the official recording mechanisms deal with this issue. And we'll talk about why that is in a minute, and while it's kind of related, and you could argue there's some time weather connection, and in theory, time is more changing the weather in this case versus weather changing time, right? but still a connection there. So no thing that I really find that said, hey, weather's the reason we do daylight savings time, so weather change time. But let's talk about that broader issue and how, again, there's another weather time connection. And you've heard me talk about this before, which is Coordinated Universal Time, or UTC. And yet don't ask why it's not cut instead of UTC, but it has to do with an agreement between the French pronunciation and then English pronunciation. But weather lives by this. We also call it Z time. Again, this is also kind of a military thing, although the military uses it more just because they use a 24-hour clock. We use it because we think on one clock. So meteorologists, even though we translate it in a local time, if we're dealing with local individuals, we think UTC, which is based on old structures of Greenwich Mean Time, which is born out of other things. And I don't want to get into the politics about why the line ended up being there, but it had to do with how many maps of note were, being produced at the time that it was agreed upon to do this other thing. But just know that essentially in the UK, more or less, the UK is the baseline of when the weather clock functions. What it calls 0, what it calls 11, what it calls, again, as we use 24-hour nomenclature, what it calls 17 or 23, whatever. So we tend to think on that. And you've heard me mention in the models before about how we use this to launch weather balloons, how we use it to earmark model runs. Just so, the world is, and that's the thing, when we're looking at this stuff, we're looking at the globe. So we have this big, large thing to look at, and we need to think about it all in the same time. Whether it's daylight or nighttime, it doesn't matter. And that's why we use it. So then you might ask, well, why don't we all use it, right? Why doesn't everybody just use some sort of UTC? And there's some validity from a weather standpoint, we like it that way. And we'd be glad to share it with everybody else. And that led to the question that came in from Aaron. Aaron, I like to call my inquisitor. He sends me some interesting questions, and he doesn't just send like, oh, why is this? He has a context as to why it's bothering him and why are goofy meteorologists doing crazy things, and I always enjoy him. So thanks again, Aaron, for giving me some material to work with. But he asked this question about highs and lows and the way that they're portrayed. So anybody who gets a local forecast, usually it's this way. You're watching the news or you're looking at your app and it says the high temperature is going to be this and the low is going to be this. But the low almost always, and for almost all these locations you're getting it from, is usually for the overnight hours after the high. And so usually in places like most of the world, or unless there's an unusual weather circumstance going on, that means that the low is physically in our next calendar day. Now, the basis of this, part of it is it's traditional, and we've always done it that way, but the fundamental basis from it has to do with something called the solar day. And this gets into the whole, why are we centered, why does the day start at midnight? But a solar day doesn't. A solar day tends to start at sunrise and goes until the next sunrise. So the low, reporting the low, was usually born out of that. Now, I was reading about some climatologists who said it's actually the lowest number, but that's not necessarily true. So if your low today or this morning was colder than tomorrow significantly, and that is not unusual, and that happens a little bit after sunrise, then the low for the day, the actual low, wouldn't be the next night. But generally speaking, it's born out of that thought process, though, in that we're forecasting until the end of the next solar day. And I've heard all these arguments about people saying, well, it's what you need for planning. Well, it all depends on when you're getting this forecast, right? But that's the basis of it. Is it structured out of this solar day origin? Whether the explanations I've seen were accurate or not. It's funny when you're reading these things and you hear someone try to clarify it, and they just create more questions when they try to clarify it. So I'm not trying to clarify it here. Just know that this thinking of it's the high for the current day that you're experiencing, and the low for the following overnight is just born out of the fact that the meteorological solar day, if you will, is thinking from sunrise to sunrise. So we don't use that delineation of midnight. And, us meteorologists are like this with other things. And even, Aaron, this one's for you. I mean, you work in hydrology stuff, but we have what's called a hydrology year or a water year. And I use that a lot, and it tends to do with starting the year at kind of the lowest point of flow. In the U.S., it's, I think, October 1 is generally observed, because what's happened is all the snowmelt has occurred. And, a rainy winter season hasn't kicked in anywhere, so it's usually at the lowest streamflow levels. But when I was in South America, that, the month was flipped. They did the same idea, dealing with snowpack and snowmelt. And seasons, you've heard me mention it before. We have meteorological seasons. We just started spring. Technically, it's not spring yet, based on the solar thing. But we do it for, we all have these reasons. And we Mets tend to like to divide things, kind of thinking of things as a sine curve, if you will. So it's got a wave-like feature. We tend to pick an apex and kind of start things there. We generally don't do it in the middle. So while the divides work for us in the type of analysis we might want to do, or the types of considerations we might want to do, it doesn't always make things easy, because it can be confusing. And that hydrological year, I have to be careful when I'm doing analysis. How is that information reported? Because it may say for the year whatever, here's the streamflow information or the rain gauge information. I have to validate if it doesn't include the precise dates. Is that a calendar year? Because not everybody always knows the conventions when they're reporting these things. But all these different ways of even looking at a day or a season or whatever it is, you have to wonder, well, why not in life, right? Why do we make things so complicated with time zones? I heard Amos, one of my friends over at the Ritual Misery podcast, complaining about, he's in Alaska. Alaska's a big place. And the time zone doesn't really make sense, and it doesn't necessarily make sense for the whole state to be in one time zone. And I butt up against a time zone, right? I'm close to where the next time zone starts. And it's an arbitrary line. I understand some of the logic. But why can't weather, and the way we think about weather, deliver a time change? Why can't we start the day at sunrise? And, instead of have midday be at the peak of the sun, as opposed to that being, some arbitrary, we talk about noon. How often is noon when the sun is peaking? Very seldom in the current time structures. We have these things skewed, right, towards more daylight hours being past noon. Sunrise this morning for me, I don't know exactly what it was, between 6 and 7 sometime, but tonight it won't set till later. Because 6 to 7 compared to noon, let's say it was closer to 7, and if I get to 7 tonight, and that's in the summertime, it's going to be even further. Sunset's going to be 8-ish. So I'm going to have more hours afternoon. So noon usually isn't that fixed middle point of the day. Now, at some point it was probably for people that were doing it. And the other thing we got to keep in context is a lot of clocks and methods of doing it were developed closer to the equator, where you have less of an issue of things you do, like in Alaska, where the sun can disappear, right? Or anybody living in high latitudes where you get very few hours. And I started to wonder, in this day and age, right, when we've got all these technologies available to us that can tell us time, that can give us time information, Why do we even need time in a 24-hour countdown sort of method? Why don't we measure everything relative to the true, zenith of where the sun is, or sunrise and sunset, and do it other ways? But then, the hours of day, like I said, if you live in a high latitude, you don't have as many hours. So would that make your working day shorter? So it's a mess all the way around. And I understand the arguments of why people don't like daylight saving time, and why the changes. But they even talked about, there's been recent studies about how it causes more car wrecks, and how it causes, even health problems like additional stressors like heart attacks and things like that. And I get all that. I can believe it's true. But if it's not that, it's going to be something else. The abrupt changes throw people off, but people travel and get jet lag all the time. And that's just, we learn to deal with it, and people get over these things. Maybe if we made it less of a problem, didn't bring such a focus on it, it wouldn't be as big of an issue. But all right, so all that, lots of time in weather talk. But was there anything interesting? Could weather itself actually change time? That's what I was trying to answer, right? And so one of the first things that kind of came across in my searches is perception. It's not necessarily changing time, but it's our perception of time. So the general studies show, and this one's really hard to test because you can't test the perception of perception when you're not in the event. And time doesn't really change, so all you can kind of deal with is the idea. But generally speaking, if you want more time, listen to last week's episode, listen to some of those weather recordings, and when you're in a less stressed state, apparently you feel like you have more time available, time goes slower. Want the reverse? Maybe become a storm chaser, because high stress events like severe weather can lead to, right, this happening to you. Time tends to perceive to go by very quickly, right? So don't do that. If you don't want time to rush away, then avoid stressful events. If you do, like I said, start looking at severe weather all the time. Although if you were doing it all the time, it may not be as stressful. So we got two other kind of times to consider. We've got our year, I guess the best way to think about it, our orbit around the sun. And then we've got how our day works. Now, the year stuff's a little trickier. I don't know. I'm sure a movie, maybe Hollywood could come up with a way where inverted tornadoes could somehow suck things in the earth and change its, I'm writing a script now, right? But maybe there would be a way to throw a change in the Earth's orbit due to the weather. It didn't seem plausible, right? I didn't see it likely. Hollywood, like I said, maybe. Not realistic. So how about today? This is really what it boils down to. End of all of this. Can weather change time? It's probably boiled up into something very simple. And this was born for me out of something I actually saw in one of the old Superman movies, and I don't remember which one it was. We're talking Christopher Reeve. We're talking, decades ago. But I think it was Lois Lane died, and he needed to reverse time so that he could bring her back to life. So he flew around the Earth real fast and slowed down the Earth's rotational spin, and then made it go backwards, did what he needed to do, and then made it go forward. No, that's not really... We're not in time travel yet. Well, we don't know. If we are, we're not aware of it. The people who are coming back in time and changing and altering our time, I think, have done a pretty good job of hiding themselves at this point. Plenty of TV shows where you can watch about how all that's happening, right? But there is this thing where weather and time are very intrinsically related. It's the Coriolis effect, and this has to do with the spin of the Earth. Now, if you don't understand Coriolis, I put a video link in there. It's one of the best I've ever seen that does a quick explanation, and it's done by Nova, but it kind of shares with you the idea of why weather kind of happens, why we get low pressure, and why it spins the way it does. Watch that. I could get lost in just doing a whole episode on that, so I'm not going to do it. But the long and the short of it is, we owe the type of weather we have to the Earth's spin. So spin changes, whether the Earth sped up, or slowed down, right, would definitely impact weather. It would. It would change how strong, for instance, a hurricane could get just by the baseline starting point. And this is all has to do with something we call the conservation of angular momentum. But what you didn't realize, so the example that's always used about an ice skater when they spin and how when their arms are spread out, they spin slower, and when they pull everything in, how they spin faster. And this also has to do with the fact that we've got an equator, we've got poles, and so the spin for everything that's going on is relative, right? How somebody near one of the poles moves versus somebody on the equator, it may not feel any different to them, but how much space they're moving over is clearly very different. And so their rate of speed change is very different. And all the science behind that delivers this way that weather works. And this conservation of momentum delivers this relationship between weather and time. And yes, while the change in the Earth spin would impact weather, weather changes do actually impact the Earth spin. You heard it, right? It's true. The Earth can have changes in its rate of spin due to the way the weather behaves. And this generally has to do, one of the biggest drivers is jet streams, some of the very strong winds, higher in the atmosphere, and how they shift with changing seasons from closer to the equator to closer to the poles. But there's also things that can reverse it that have to do with, when glaciers melt and how that changes the water balance and what that does to the planet. So some things speed it up, some things slow it down. So weather does change time. And weather can change time. But do know that relatively speaking, the impacts are measured in milliseconds. That's right, a thousandth of a second. So we're not talking much. So can weather change time? Most definitely. My original premise and hypothesis stands. Weather can indeed change time. Does it change it in a meaningful way? Not on your life. It's more likely to. There's probably some better theory about how the weather is responsible for daylight saving time, which I could find. But in any case, weather can change time. It happens all the time, and it is monitored and accounted for and all those things. But probably what's more interesting is how much time would change weather if our days were to get longer or shorter. Heck, how we would even adjust as humans. Again, a few minutes here or there, we're not going to change it. But can you imagine if we didn't rotate, like if we were something like Mercury, what that would feel like if you were on the dark side versus the light side and what your weather would be like? But just know, the next time you're looking at a timer and you want it to speed up or slow down, if even just for a fraction of a second, maybe you should wish for faster or slower jet streams. All right, enough about time. I hope everybody gets through their daylight saving time change without too much effort. And I came across an interesting tidbit along those lines. And I'll leave you with this thought, that most of the world, for those of us who are complaining and just frustrated with daylight saving, most of the world does not observe daylight saving time. And there's a lot of good reasons for that. Near the equator, as I was kind of alluding to earlier, it's not as beneficial. There's no real need to do it. But lots of folks just don't do it. Heck, there's even whole countries like China that have one time zone. I think that's more problematic than daylight saving time. I couldn't deal with that. I guess you can if you're in the locations that it works for, but not if you're in one of the remote areas far away. May your daylight saving time, like I said, go well, and may it be not so distracting. So in the grand scheme of things, that you have some time and some possibility to say, hey, this is not a big deal, and I'm finding the weather much more interesting, or I'm finding my weather's relationship to time more interesting than distracting. And may all that help you have an enjoyable and an interesting weather week. And just know, as you're looking out there, that somehow weather is at play. And don't forget about that, because as we all know, there's much more to weather than the weather itself.
This is two White Sofa production.
We're tired of hearing our uncle grovel, so please support him on patreon.com/weather.